Today, we're going to learn about balancing redox reactions in acidic and basic solutions. So, what I like to do for these problems, there's 5 simple steps I like to do to help me tackle these problems because they are pretty difficult. So, the first step is to write the half reactions that are in this equation. So, the first one you see is iron 2 plus aqueous, and that becomes iron 3 plus aqueous. And then the next one we see, I'm going to put it a bit further away. So you have a form of manganese oxide. So there's here manganese oxide, it's an aqueous, and it becomes just a cation of manganese right here. So Mn2 plus aqueous. So anytime there's a problem like that, this is always the first step. It makes it super easy. Now you have 2 different angles to attack the problem. So the next step is very important too. What I like to do is balance each half reaction. So for this one, in terms of like atoms of iron, it's the same, so we leave it as that. But in this question, however, there's oxygen. Now what we might be thinking, what do we do with oxygen? There's one simple thing we can do, and that's add water. So we add water to this right-hand side to balance for the oxygen, H2O. However, there's four oxygens here, and only 1 here, so we need 4 oxygens. Now, I know you're smart, and it's so confusing because we have now 8 hydrogens on this side and none here. So what we do is now we add just protons to this side to balance. I don't like this green color. What other color? I'll use red for later. Let's add this one. So we add, we'll add some protons. But this side, there's 8, right? There's 8. So let's add 8 on this side. Now, this half reaction is balanced because we have 8 hydrogens on both sides, a manganese, and 4 oxygens. So that's step 2. Now step 3, I'm just going to move this to the side a little bit. Step 3, now this is where it involves the balance charges. And how do we balance charges? By adding electrons. So in this one, it's 2 plus charge, 3 plus charge. So on the right-hand side, we can just add 1 electron. And then now this side has a 2 plus. And this side also has 2 plus. So this one's a simple one. However, on this side, it is not so simple because we have 8 plus from the hydrogen and a minus 1 from the oxygen. And we have a 2 plus here. So we know this side is plus 7 charge and this side is a plus 2 charge. So we have to add 5 electrons to the left-hand side to balance, right? So now it's balanced as well. And now from just in general electrochemical knowledge, which one is the reducing, which one is oxidizing? I like to remember, Leo, the line goes gur. Oh. Lose electrons oxidizing. So this one is losing electrons because it's on the product side. And then so this side is gaining electrons. So it's reduction. Okay. And now the next step, step 4, is to is to multiply the half reaction to get an equal number of electrons. So this has 5 electrons, this has 1. So what do? We multiply this side by 5. So now you have the 5 on everything. 5 electrons. So it might be confusing why we do this, but the next step will make it a lot easier to understand. Now we have to combine both of these half reactions to get an overall reaction. So I'll do it right here. So we have 5 iron 2 plus 5 electrons plus 8 protons plus 1 manganese oxide. And now we're going to the other side. We're 5 iron 3 plus 5 electrons plus cation of manganese plus 4 H2O. This looks like a lot, but there's some stuff we can cancel out. You see here the electrons. That's why we balanced it earlier. We can get rid of it like that. And yeah, now we are done. So, well, okay, I'll just write it like this, make it more clear. And then once you're done this, now we're done. And a way I like to check to know if I got this right, or yeah, to know if I got this right, is you look for the charge on both sides. So this side has a 2 plus charge. Oh no, sorry. This has so this is 2 plus 8. No, this is wait. This is 8. This is 10 minus, this is 15 plus 2. So this is 17 plus, and this is also 17 plus. So that makes it really easy. Now, for the basic solution, it's all the same 5 steps for acidic. But then what do we do next? Is we add number of hydroxide that is equal to the number of H plus. So let me write this down again. Plus makes 5Fe3 plus Mn2 plus 4H2O. So what you do is you add 8OH minus, and then now when you have an OH and H, you can have water. So now you have 8H2O, and then you're left with plus 5Fe2 plus MnO4 minus. This is a grueling process, but it makes it easier to understand and to get the question right, of course. And then now you have 8 H2O on one side and 4 on the other, so you can cancel, these go out, and this becomes 4 H2O now. And then yes, it's plus 5Fe2 plus Mn4 minus 5Fe3 plus Mn2 plus. And yeah, and then now that's what you do, and now you're in a basic solution because there's no more protons. So thank you for watching. Hopefully makes it a bit easier to understand. And yeah, thank you.